All right, so you just took your test on the second part of Unit 6, so we are now in Unit 7. We started it on Thursday with slope fields, and we're going to be working with differential equations. So the first thing we're going to do is we're going to verify differential equations so that when we learn how to solve them, then we can verify that what we have is right. So here's what this says. A solution to a differential equation is a function, y equals f of x, that satisfies the differential equation when f and its derivatives are substituted into the equation. To verify, we can substitute derivatives and the suggested solution into the differential equation. Okay, so here's what this means. This says to verify that this function is a solution to this differential equation. So that means I need to substitute y double prime and y into this equation to verify that it works. I have y, I do not have y double prime, so I need to find it. So let's start, we have to start with y prime. Take the derivative of this first term. I'm going to have to use the chain rule because this is a function inside of a function there. So the derivative of cosine is negative sine, and then I'm going to have to multiply by the derivative of 2x, which is 2. So this is going to give me a negative, and then that 2 times 4 is 8 times the sine of 2x. I leave that argument alone. Plus, the derivative of sine is cosine. Have to use the chain rule again. And then the derivative of 2x is 2, so I'll take that 2 times 6. That gives me 12 times the cosine of x. Okay, so there's y prime. Now I need y double prime. Chain rule again. Derivative of sine is cosine. Derivative of 2x is 2, so this will give me negative 16 times the cosine of 2x. Derivative of cosine is negative, ooh, look what I did. I messed up there, dang it. I'm not starting over again, so already started over twice. 2x. You leave the argument alone. All right, so derivative of cosine is negative sine. Derivative of 2x is 2. So negative 2 times 12 is 24 times the sine of 2x. Okay. All right, so now that I have that, I'm going to substitute into here. I'm going to take my y double prime, which I just found, which is negative 16 times the cosine of 2x minus 24 times the sine of 2x. Then I'm going to add to it 4y, here's y, so plus 4, open my parentheses, 4 times the cosine of 2x plus 6 times the sine of 2x. So then I'm going to clean this up. Oh, and this is equals 0. That's an equation. So then negative 16 times the cosine of 2x minus 24 times the sine of 2x plus, then I distribute my 4. This is going to give me 16 cosine of 2x plus 4 times 6 is 24 times the sine of 2x, and that should equal 0. So I go to clean this up. I have negative 16 cosine of 2x, positive 16 cosine of 2x. Those 0 out. Negative 24 sine of 2x, 24 sine of 2x. Those 0 out. 0 equals 0. There I verified. Okay. Now, in example 2, it says determine. So let's look at these words here. Let's think about what this means. This says verify. Ooh, doesn't need to be that big. This says verify. This says determine. Those are two different things. When you see verify, that means it does work. Show me that it works. And all of this is you showing that it works. Okay? That's what all this is. Determine means maybe it does, maybe it doesn't. You tell me whether or not it does. Okay, so let's look at the first one. Determine whether the given function is a solution to this differential equation. So I'm going to need f double prime. So I'm going to start with f prime of x So the derivative of cosine is negative sine, so that makes this sine of x. No need for a chain rule because there's not a function in a function. Then I need f double prime of x. The derivative of sine is cosine of x. Okay, so then I'm going to substitute it into this. I take f double prime, which is cosine of x, and then I subtract f of x, so minus negative cosine of x, and that's supposed to equal 0. Well, this is cosine minus a negative cosine, so that gives me 2 cosine of x equals 0, and that does not equal 0. Okay, so that means this one is a no. If I get 0 equals 0, my answer is yes. Okay, this is not like solving for this, you know, because yeah, if this was an equation, I could solve for x in this. That's not what we're trying to do. We're trying to see when I actually do this over here, do I get 0? And the answer to that is no. Okay, so you are going to do the rest of these. You can work together, finish B and C on here, and then the ones on the back, and then I should see you tomorrow. Be good little boys and girls, and be nice humans.